Hey guys, so here's what should have happened after you got done with this activity. I did the same thing you guys did. I went into this website, started creating a bunch of different circles, took their diameters and their circumferences, and I put them into this data table right here. So try to be diverse about it. I had a small circle right here. Obviously, it's got a really small circumference. Had a pretty big one right there, a couple of medium-sized ones right here. And then these were the resulting diameters after I made those circles that big. Over here, I had already put the formulas in there, but if you want to see how I did it, anytime you want to put a formula into Excel, you start by typing in the equal sign. And then what I want to do is I want to take this cell right here, which represents the circumference, and then I'm going to go on my keyboard and hit the divide key. And I want to divide it by the diameter. So I click that, I press enter, and it ends up being 3.14. Now what I'm going to do next, so I can make it faster, is I'm going to click on this cell. You can see it doesn't have 3.114 in there. It actually has this formula right here. So I'm going to copy and paste that formula in there. Now it didn't copy the 3.14, it copied the formula. So you can see here, now it says B6 divided by C6. Over here, whoops, over here it says B7 divided by C7, B8 divided by C8. So it's just taking those cells and dividing them. And what do you notice? Hopefully you notice that you get the same number every single time. And I'm hoping that that number reminds you of a very famous number that we've talked about in the number sense unit, and that number is pi. Now these are only the first two decimal places of pi, and if you dove into this a little bit deeper, this might surprise you, and I want to make sure that I reference this. Pi has a bunch of different decimal places. It has an infinite amount of them, to be exact, and I know some of you have memorized quite a few of them. I think I have 10 of them memorized. I've got 3.1415926535, and that's way more than any person really needs to know. So, but if you look that up, you'll see that those are the first 10 digits. Problem. If I add more decimal places to this, and I hid these on purpose, but if I add more decimal places to this, you're going to see not only are they not the same number every single time, but they're not pi. This is supposed to 1.1415926535, and it doesn't. Either does this one, this one, this one, or this one. Now the reason for that is because this is not the circumference. This is a rounded version of the circumference. Same with this. This is not really the diameter of that circle. This is just a rounded version of that diameter. If I wanted to get this to work out to be pi exactly, I would have to know the exact circumference to the infinite decimal place and the exact diameter to the infinite decimal place to get this to work out to be exactly pi. Now, if you guys remember correctly, I had you go to 3 decimal places when you were picking your circles, and I did that on purpose because I knew that if you go to 3 decimal places, it will for sure get you 2 decimal places into pi, and that's what most math books will do anyway. 3.14 for the most part. If I go to another decimal place, you can see these two worked out perfectly, but these ones rounded a little bit differently. Now what's kind of cool is that if I take this data right here, let me go to another decimal place right here. I already took the liberty of taking that data and plugging it into Desmos. Check this out though. There's all that data. The X is going to represent the diameter, the Y is going to represent the circumference, and maybe you remember this thing called a symbolic rule that we did a couple months ago, where y equals, we always had a slope and we had a y-intercept. So guess what happens when I type in the slope of 3.14? Oh my goodness, look at that. It goes right through those points right there. And then this obviously has a y-intercept of 0, so I could put in a +0. And voila, we've got a symbolic rule that can also show us the relationship with pi. Pretty cool.